This lecture in Chapter 7 is going to deal with reactions of metals and nonmetals that you're going to now call oxidation-reduction reactions or redox reactions. So oxidation-reduction reactions, these are reactions between metals and nonmetals, and you see a transfer of electrons. We've talked about that when we talked about naming, because we noticed that there are true metals and transition metals that tend to lose electrons and become positive. And we see this down here with magnesium. Magnesium is in group 2. It tends to lose 2 electrons to become positive. And then we have the nonmetals that gain electrons and become negative. So we have magnesium losing 2 electrons to oxygen, oxygen becoming negative. This transfer is called an oxidation-reduction reaction. One of the things I want to show you that sometimes confuses students, if you look here at the magnesium, if I were just to have a piece of magnesium, and you've seen the magnesium wire and ribbon that we have in the lab, its charge is 0. It is just a piece of ribbon. There's no charge to it at all. Oxygen out in the air, O2, overall charge is 0. But remember, when you go through a chemical reaction and transfer electrons within this, there's actually positive magnesium ions with a +2 charge and negative oxygen ions with a -2 charge. They're being held together by that bond. So they're going from 0 charge to a +2, 0 charge to a -2. That's a transfer of electrons. So this classifies itself as an oxidation-reduction reaction. Okay, on this concept check, you'll notice that there's a picture, and it wants to know which of the following best describes what is happening in the following representation of an oxidation-reduction, or redox, as we call it, reaction. So if you notice here, the aluminum atoms that are out here have no charge at all, and the iron and the oxygen are bound together in iron 3 oxide. So it takes 2 iron and 3 oxygen, the Fe2O3 compound that's here. So we have a displacement where the iron is going to be displaced by the aluminum. So this is a single date switch. So we have a date, and aluminum decides to kick iron out of the way and take the date over with oxygen. So iron then goes from this +3 charge to a charge of 0. Aluminum goes from a 0 charge to a charge of +3. Oxygen stays the same. So this is an example of a redox reaction or oxidation-reduction reaction. So which one of these is true? Metal aluminum gains 3 electrons. That is not true. It becomes +3, so it loses 3 electrons. We have to look at this one, so it's not gaining. So does aluminum lose 3 electrons, and oxygen in the Fe2O3 gain those 3 electrons? No. The metal aluminum loses 3, and the iron 3+ and Fe2O3 gains those electrons. And that's what our answer is for this equation. Let's look at the characteristics of redox reactions. The first one is a metal and a nonmetal reaction can always be assumed to be redox because we're transferring electrons. The second one states that 2 nonmetals can also undergo oxidation reduction. And for our purposes, we're going to look at this as being the case where we have O2 as a reactant or as a product as an indicator that it's also a redox reaction. Section 7.5 is short, but it helps us to learn to identify redox reactions. In the next lecture, we'll go ahead and break redox reactions down into 3 other categories that you can also classify them as.